So welcome to tutorial 6.1 part 2. This is on reading the electromagnetic radiation chart that we're going to need to distinguish different types of light. It's just basically it's a skill of reading a chart and not much else. So let's have a look at the first question. What kind of light would we refer to that has a frequency of 5 times 10 to the 16th hertz? That is, if 5 times 10 to the 16th waves pass in a given second. What kind of light is that? Well, we look here, there are two set of numbers here. On the bottom, we have the frequencies, and at the top, we have the wavelength. So be careful when you see these questions. The frequency is what's asked for here. So we're looking at these bottom set of numbers. And notice these bottom numbers get larger as I go to the left. That is, I have more and more frequent waves when I pass from radio to microwave to infrared all the way up to gamma. Many, many more waves in a gamma when you have gamma rays compared to radio waves per second. So where's this number, 5 times 10 to the 16th? I see 10 to the 16th is right here. And remember, the numbers are getting larger to the left. That's a little unusual. You know, we're used to a number line where they're getting larger to the right. So they're getting larger to the left, so we must be about halfway between these two. So it lands us about right here, and it looks like we're talking about X-rays. So I try to make that very explicit on the next slide. 5 times 10 to the 6th is somewhere between 10 to the 16th and 10 to the 17th. I think I misspoke, 5 times 10 to the 16th. So it's between here, halfway, and as we can see, it's an X-ray. Don't make the mistake of thinking it's an ultraviolet because you're so used to numbers getting larger to the right. Okay, let's try another one. What kind of light has a frequency of 5 times 10 to the 14th? Same logic. I find 10 to the 14th. There it is down here. I remember the numbers are getting larger to the left. Looks like I'm landing about halfway between in this kind of whited out area. Well, that's because that's visible light there between the infrared and the ultraviolet. So typically, besides saying that it's visible light, we usually want to know, what color it is. So we'll say, oh, okay, I can see that it's visible. It's in here someplace, but can we find or discern what the color is? How can we figure that out? Well, in order to do it, I have to use that inverse proportionality relationship that we had last section to say the speed is always equal to the wavelength times the frequency. So I take the speed of light, I divide by that frequency that was given, and I end up with 6 times 10 to the minus 7th meters. That's fine in terms of knowing that it's visible, but I still need to convert that into nanometers in order to be able to read that chart where it shows the colors. So how am I doing this part? I didn't write it out. I simply say, look, I'm going to simply multiply this by 10 to the 9th nanometers per meter. Nanometers are 9 powers of 10 larger than the base unit, the meter. So when I multiply a number like this times 10 to the 9th, the 10 to the minus 7 drops out, and I still have 2 powers of 10 to move that decimal place over twice. So you kind of get used to these numbers. Something times 10 to the minus 7th is typically visible light in the unit meter, which will be a certain number, several hundred nanometers in that unit. All right, so 600 nanometers, what kind of light is that? So the next thing is just to kind of read it. And again, we have a small problem on the chart. I say, well, I see 600 is right here. What shall we call that? And I said here orange. Yeah, maybe, but kind of, I don't know, maybe yellow. I can't quite tell, and it's a little bit arbitrary what to call it. But on the quizzes, I give you a different chart so that you can say definitively or with certainty what the color is. So look at this chart. We're looking for 600, so we can tell it's here between 590 and 620, like about over here, and this O refers to the color orange. This is red, orange, yellow, green, blue, and violet. So this is just a chart so that we can all agree what color that we're looking at. Good, so we said that that is orange after all. Well, let's try one more. This one asks for what kind of light that has a wavelength of 5 times 10 to the minus 8th meters. And here the part that's slightly confusing is that now with wavelength the numbers actually get larger to the right like we're used to. But because they're these negative exponents, it also confuses slightly. So let's have a look where we can find this. First of all, find 10 to the minus 8. Yeah, there it is right there. And we're looking at this top set of numbers. And I want to go to the right because numbers are getting larger to the right. So about halfway between 10 to the minus 8 and 10 to the minus 7 lands me about here. So it looks like it's an ultraviolet light. But if you're used to this bottom chart, you might start thinking you're going to the left again. But remember, here the numbers are getting larger to the right, increasing wavelength to the right. So it's ultraviolet, and we can see it, and we're just double checking to make sure we're clear. We're between 10 to the minus 8 and 10 to the minus 7, in between these two, and therefore you know it's ultraviolet. And I think that's about it. Oh, one last type. If you're given a chart like this, and someone says, gee, what kind of frequency would you have if you had, say, yellow light? Start off with a definitive determination for yellow. We already saw what that was. Yellow light is kind of in here. We can go like with 580 or so. But it's in the unit nanometers, so what we're going to have to do is take those nanometers and we're going to have to divide by 10 to the 9th nanometers per meter to get them into the units meter so that I can figure out what the frequency is. So let's try that. 580 divided by 10 to the 9th. 9 powers of 10 is what a nanometer is compared to a base. Leaves me with 5.8 times 10 to the minus 7th. And once again, like the last section, I'm just going to divide that into the speed of light. Here's the math worked out. Speed of light divided by that wavelength gives me the frequency of 5.17 times 10 to the 14th. That's it. So it's all about reading this chart. And like I said, I think the big thing that's confusing is that the numbers get larger towards the left on that bottom part where the frequency is, the way it's listed, and the normal way at the top. But with those negative exponents between the two, it's easy to get a little tripped up. So we just practice that a little bit until we're good at it. But I don't think it's going to give you any trouble. All right, great. We'll see you in class. Thanks.